So from the last lecture, the 2-23, I meant to get that into a drawing and actually generate that whole call-out table. So I'm going to pull this back up. I made a few modifications. I'm also going to use this in the CAM class to program and talk about fixturing and different approaches to machining this. So I made one of these a countersink. We already made the one threads, and so there's some different types of geometry for the call out. So if we go into the new, and we'll use well, let's go with the tutorial. I still need to get the templates set up. So into the view palette. And that one's open. So we'll do a front view and a top view. And right-clicking on the view will bring up our in context. The very bottom is tables. And general table, you can define and enter all of the data. Whole table is what we want. Bill of materials is for the assembly. Revision tables can become part of your revision scheme, puts the block, kind of describes what was done. Weld tables, descriptions of the weld beads and basic terminology. Bin table and punch table for sheet metal. All right, so I'm going to select whole table, and it's going to go find the default standard whole table template. If we wanted to make any changes, we could save a custom template back, but most of the time this standard whole template is going to be fine. We attach it to the anchor point of the template. Usually they are the corners, the edge of the title block, some information. And just like well, we got the origins turned on, but just like in the drawing, we're going to generate an x-axis, a y-axis, and then that automatically defines the origin as the 0 point. And the holes, let's see, if we go with the entire face, I believe the entire face will also find the square pocket and the odd round slot. Okay, so we'll put it in we don't have a layer, so nothing to select. And let's go ahead and accept it. And it's going to warn me non-circular holes or radial slots in the hole table. Center points for such holes are not constrained. Center location is approximated. In the hole table at the center hole geometry, hole size is not supported. So this is where the table comes in. Alright, so just a little bit on the large side. Keep in mind that the four-headed arrow in the upper left will allow you to drag, and you can also click, and that will give you the attributes or the things that you can change for the whole table. So the one that I'm usually interested in, if I can find it, let's see. Combine same size or combine tags. All right, so combine same size is going to reduce it down instead of repeat. All of these are that size. And then it also comes back to whatever D1 is pointing to my weird slot or my weird square through the center. And J1 then is the slot, so it's giving basic dimensions on the slot as well. And like it said, it's pulling off of the center point, not necessarily dimensions. So if we need additional dimensions, we'd have to add them manually. All right, that gives enough information to get started, yes?
And that magic only happens if you've generated the holes using Hole Wizard, right?
For the most part, yeah. Because the slot and the through hole were not generated by Hole Wizard, they'll still be included. If you want it to recognize the drill diameter and the tap, excuse me, the tap, that would have to be a Hole Wizard item. The countersink hole wizard item. If it's just a set of through holes, if I had left this alone and everything was in one sketch, I believe it would still recognize the holes as the geometry and divvy them up on size, but you would not have the additional the tap or the countersink or whatever geometry we're looking to put on there. The table, also the precision, we did this in 2 decimal places. I want to say the table is, we'll double check here, should be document units, but since everything was 2 places, I don't know that we'll get that back. So guess we could try changing one of them. So one of that would have been 250. So let's see what the part units are in. So part units were 3 places. All right, so I'm going to put a 161 on something and 921 just to see if it shows up on our chart. Okay, so once it saves, so no, not really. All right, so one of the ongoing issues, I guess, with the tables has been setting the and I want to make sure I didn't jump over it. There we go. Hole location precision, 3 decimal places. There we go. All right, so different tables will pick up. I want to say the units kind of sometimes randomly, it seems like. But if we go back into the parameters for that whole table, was able to locate the precision, and that is updating all of our values to 3 decimal places. If this whole table gets big enough, we can add a sheet. And let's see, we'll go with the landscape. So I can come back and highlight, Control X, come over to the new sheet, Control V, and place it on an additional sheet. Most of the tables are capable of being split. So split horizontally above, horizontally below. So let's just go with below. And I could bring that one out, one additional. Usually the recommendation though is make sure that you're fully through the design and that we're not going to add more quarter 20s, or we're not going to add more so that we have to combine them again, find new places to split as these numbers kind of shift, because if I've run this all the way to the end, it will add to this group and grow into my title block. And the only way is that I've been able to find, haven't done it in a while, so there may be some new ways, but is to tell it to combine or merge the tables back, and then so merge with next or merge all, and then split them out again so that they fit across multiple sheets. And I've had parts that have generated enough hole locations that they went across multiple sheets. All right, so just a quick reference to the information that you're seeing in the book. I had talked about that. We can go ahead and save it. I talked about the you can generate the whole tables in the drawing, but then we didn't. I didn't pick it up and run with it. So, all right. So back into the templates. All right, so at the top of Chapter 3, Part 1, this kind of starts the, again, read the instructions. If you are using the book, take a moment to just log in and look at the top portion. And projects 3-10 through 12, so I'm trying not to dump too much on you. Best recommendation is that if you can do all of these and you have the seat time and are interested in, everything that you draw adds something to your toolbox. If you're pressed for time. These are, again, not meant to be a misery fest. Do the 12 for the assignment, and then come back to them later. Come back to the ones that aren't part of the assignment later, if you're so inclined. All right. Also at the beginning will be the known issues and errors. So the note 313, down a little ways. Okay, so this block is one of the exercises in the chapter. I don't entirely agree with, and over the last couple of semesters I've done this every different way I can think of, and used some of the different in conditions to generate it. But if you want to try and follow along with the book, this one is an exercise example in the chapter. Right-faced angles, holes intersect, towers extrude through. So I try to give you some basic information that if you're looking at the drawing and it's presenting a problem, this would be a good place to look at. Kind of help you, give you some direction, make a decision. At the end of the day, if it's not clear geometry, you are the designer. You get to decide, right? I live and die with those decisions every day. And then I get into on the advantage of the manufacturer side as I start making it, and I go, oh, hey, that would be a much better way to do that. And I make a design change at the machine, and then run back to the software real quick and update it, and tell SOLIDWORKS, this is what it looks like now. All right, so so we'll stay with. There are 48 projects in Chapter 3. You're responsible for half of them. When we go over to the drawings, the second part, when you look at the Chapter 4, what they put into their drawing mix, they were 75-80% the same as the end of Chapter 3. So just use what you've already created in Chapter 3. You don't have to redraw anything or remodel anything. You're going to bring it into the drawing, put a couple of dimensions on it, and just get into the workflow. If you're looking downstream to chapter 4, if you're going to be doing detailing and the drafting side of it, then spend some more time with it. Look at the section views, push all the buttons, see what it looks like. The bare minimum, I'm looking for Chapter 4, I'm looking for 3 views, an isometric, and that you put some dimensions on the part. Not ANSI Y14 specification, all the way down the perfect drawing. Just that you understand the process. Okay, so I'm going to start with Chapter 3, and I'm going to attempt to do all of these if we don't get too crunched for time. Looking at some of these, the first handful, and I guess you would say that was why I started with 3-10, is some of these are a little on the easy side. All right, so stair steps and the geometry. We're kind of starting out with Chapter 2, but instead of being a 2D sketch, a 2D drawing, we're going to start looking at this from the isometric views and start looking at it in terms of depth. And then the multiple features, if you haven't started, you will now. All right, so if you haven't done separate features as cut extrudes or separate features as fillets, this is going to force you down that path with the strategy. All right, so 40, 30, 15. I was looking at this thinking, I really want to make this more complicated than it's worth. So I'm going to introduce global variables. And it's another one of those, it's a handy tool. So I'm just going to sketch the stair steps. And global variables fall under the category of an equation. And we have an equation manager. And I am in metric, of course, because I didn't stop and look at my drawing. So we're going to go back to millimeters, grams, and seconds. Edit the sketch. All right, 40 millimeters by 40 millimeters. So if I wanted to, that could be my first global variable. All right, so you can build them all at once or you can build them individually. We're going to go over to Tools, I think. I always have to look for it. And towards the bottom will be Equations, and it's going to come up with the Equation Manager. Very simply, we're going to set, let's see, height and length. And to a certain extent, it follows the kind of the old DOS rules of no special characters, no spaces, not necessarily limited to 8, but you don't really want to write a novel either. So maybe I'll just go length on this. And then when we hit the tab, it'll jump over to the value of the equation is 40, 40 and 40. So since I'm going to put in the steps next, I'll go ahead and put those in, and they'll be 15. And we can hit OK. All right, so the other side of this is feature suppression. We talked a little bit about suppression. I can pick those items and control its suppression state out of the equations. And then equations are probably, if I took length, I would set up the global variables, and then if I took length plus the steps, I could set up an actual value that says go back to this global variable and add it to this global variable to generate an equation. So I won't make it that complicated, but just to run through the process, and with the for a what-if scenario, this is kind of a good intro technique to just be aware of some of the places that you can use it. So instead of entering a value, I'm going to hit the equal sign. And equal is going to pull up global variables. There is my length, and OK. And I think I closed it. I didn't hit the, wasn't paying attention, hit the OK. All right, so the other ones are the functions, the math functions. And then the file properties. If you start in with the functions and write it in, it will, I'm going to say add it to this equation, or it'll show up as a driving dimension, but not necessarily generated out of the variables. Okay, so there's the length, and double click equals global variable length, and OK. All right, so notice that we get the little sigma sign that says this is equation driven. And as we apply the next values, instead of entering those values, I'm going to go global variable steps. Okay. All right, and then the last one should have been whatever was left. Oh. Okay, have one more. Nope, that was not what I wanted. All right, one more equal. Okay, so this is going to be very similar. Let's see, I probably should have looked at that one first. Maybe we'll do that with the with some fillets. Anyway, this is going to be similar to linking values. The advantage, though, is that the global variable can participate in the extrusion. The global variable can participate in any of the other geometry and across features. It's not limited to this sketch. All right, so when I go to extrude this, extrude boss base, same thing. This is highlighted at 10 millimeters, equal global variable, set my length, and it goes to 40. All right, so as we go through those values, now to change those, we'll go back to the equation and right-click and manage the equations, and maybe I want to go to 60, and if we'll cooperate, we'll go to 20. We rebuild, and there are the steps that went 20, highlighted, updated, 20, and 60, and 60. So it's kind of a starting point to be able to drive multiple dimensions. All right, so we'll revisit that again. It's just kind of an introduction, introductory type item, just to introduce the concept, not doing anything specific with it. Something for you to try to tinker with and see what kind of results. Find some places where you can utilize it. All right, setting up my folder for chapter 3 then. This is going to be 3-1. I'll save. And we'll check the next one. All right, so looking at this, we have the steps, different sizes. I kind of look at this and I want to try and get the most bang for my sketch, bang for my buck. All right, so looking at this bottom profile, this kind of L shape, I think that's what I'm going to start with, and I'm going to extrude up to this first level. And then it'll be cut through, cut through. Everybody is going to see this different. If we wanted to, we could start off with a cube that was 3 by 2.5 by 2.5 and whittle away the material. That is a good strategy if you're going to illustrate machining processes. I want you to set it up this way first, and depending on the complexity of the part, go through the process of remove this material, second step, remove this material, third step, remove this material. So we're cutting and whittling away at the part. But for the most part, we're going to keep adding geometry, and this was 1 inch. So this is going to be in the top plane. We rotate into position, and it's going to look something like and missed. All right, so 2.5. Three, 2 inches, and 2.5 inches. And it gave me an overdefined. Oh, that was 2.5. So I shrank that to 0. 1.5. There we go. All right, so since this line would have shrunk to 0 with the 2.5 dimension, that's why it was unsolvable. We're going to extrude, and this is going to a height of 0.75. Nope, 1.25. Okay, and that's going to be the 0.5 plus the 0.75 to the top of that first level. Direction-wise, let's go with one of the corners, and we'll go to a Control 3, and this can be just a corner rectangle. And that one was, so not a good choice. Well, considering that our dimension was from the bottom, because that edge is either lying in the plane or is able to be projected into the current sketch plane, it's going to be valid geometry to sketch to. So keep in mind that you're not locked into just your sketch geometry. Anything that exists and is valid in that sketch plane, you can dimension to. So that was what was missing. All right, so the guess is, what are the inside steps? So I'm going to go with a 375, so 3/8 of an inch, and then we're over to extrude cut. All right, boss is adding on material, cutting is removing it, and we'll give it the through all. And this is where we'll start to see more of the end condition. Through all finds the last available piece of geometry. Up to next stops at the next, the end of that face or end of that geometry. And there may be times where I want it to stop here if there's geometry on down the line that would interfere with, then I would switch over to up to next as opposed to letting it go through all. All right, so we'll go sketch and rectangular. And we'll do one at 0.5, and I'm just basically mixing it up. It's not anything, since the dimensions aren't there, take what we can get. All right, so sketch, rectangle, go from the corner, and we have 1 inch by 1.5. And then the total on that was 2.5. So this is, well, we can certainly do the math and come up with 1.25 from 2.5 is 1.25. But again, making it more complicated, because at some point you will be in a situation where that math is not going to be convenient. So going over to offset from surface requires that I select something, and then I'm going to give it the full dimension, 2.5. And we can reverse the direction, and it will calculate from that face up. Okay, the other thing that we could do is I could leave that as a blind condition, and on the sketch plane, the from, I can move this the sketch plane to that surface, and an extrusion through an extrusion, as long as this is merged, is no net gain in volume, or mass. Right? It's just they're intersecting and it's joining them together. All right, so it doesn't quite look like they're the picture, but numbers add up. 1.25. If I rotate over and grab the faces, 2.5. That much of it makes sense. All right, so the advantage. Let's see. Go back into the feature. Advantage of the from is this is going to be easier to use. Advantage of the offset from surface, if this was curved or cylindrical or had some wavy shape to it, offsetting from surface allows me to translate against that surface, to maintain the curvature, to maintain the geometry through that region that I'm extruding. So I'd say be aware of those and experiment where you can kind of identify some of those locations. The other side of going through all of those in conditions is very rarely will you use maybe offset from surface or up to surface, but having it in a technique, having it something that you're aware of, and understanding how it works, that's kind of the jumping off point. Okay, 3-2. All right, so I am kind of going, I won't say the obscure way, but I'm not necessarily the way that I would have would create these. I probably would have just drawn the first technique, extruded up 1.25 and called it good. But there are very good reasons that we may want to go from that bottom surface and shift up. All right. So 3-3, we talked a little bit about thin features. So 3-3 and 3-4 are items that I wouldn't say they lend themselves, or they do lend themselves. Again, I don't know that I would automatically pick a thin feature, but again, be aware that it exists and how it works. All right, so we're in metric 80 by 40. And didn't see a depth, but we'll pick that up. All right. So front plane sketch, I'm going to put this on the midpoint. And one of the conditions for a thin feature is that all of these lines have the same thickness. All right. So we're 10, 10. 10, don't see any other values. And I mentioned before that we kind of get in the habit of putting the lower left of our sketch on the origin. Keep in mind you don't have to. It's not a requirement. I can go to a midpoint. Let's see, those are going to be collinear. We'll set a few dimensions. Nope, I don't want an angle. So 80, 40, and then the length, 30 in two places. So they'll set those equal. And that's as far as I need to sketch. Features, extrude. Because of that gap, it automatically jumps into thin feature. In fact, it grays out thin feature and says, you have a thin feature. You're not getting another choice. The blind ink condition for the depth, 20, and then let's just say that that's half, so we'll go with 40. And I want it to go forward, back, or midplane. Doesn't really matter, since I'm saying that this notch is at 20 and that looks like about halfway. I'll see if I can use the origin or the mid or the front plane to help me dimension that geometry. All right, so my magic crystal ball of design intent is I'm either really making some really cool decisions or I'm painting myself into a monstrous corner. Also notice that this is projecting outwards. So we're doing the thin feature one way, midplane, or one or two directions. So that would have stretched it up to 20. And we have the toggle button to reverse the direction. That was what I was looking for. And then if this is kind of more along the lines of sheet metal, we can tell it to auto fillet, and it will do 5 millimeters on the interior and plus 10, 15 millimeters on the exterior. All right, don't want auto fillet, but there are places where I've done like basic architectural extrusions or something that have that little bit, or it's a bent item that doesn't really need to be sheet metal, but needs to have the fillet in place. All right, so there's my geometry. Notice it says extruded, then 1. All right, moved away from the boss. That was picked as a strategy. Can open the sketch, and I'm not rotating normal to, so we will go and see if I can get away with just the one dimension. So 10 millimeters on the height. Let's see, does that add up? 15, 10, not quite centered, is it? 25, oh, yeah, it is. Okay, when I can do math, select midpoint, control select, go to midpoint. I'm going to automatically center it, and then I want to automatically center it again by making it coincident to the origin. So be aware that you may open up somebody's sketch or open up a part at some point, and sketches may not have any dimensions. It's all related or all related to some other geometry. Your job then is to trace it back and go, okay, that one goes there. Oh, there's a midpoint to that geometry, and then coincident to the origin. All right, when I extrude cut, here's a place where when we look at through all is going to fail. It finds my far piece of geometry, not the desired result. So up to next is going to stop it short. Up to vertex, we pick the intersection, pretty much the same result. All right, so I can pick, and based on the preview, I will get different results. Let's see, up to surface, we'll pick the surface as opposed to lines or the vertices. Offset from surface we kind of did, but this would shift it some direction. And it was already 10 millimeters, so I don't know that that's helping, but let's reverse. And so just 10 millimeters beyond that surface. Up to body, we only have one body, so not going to help. And midplane, not really going to help. So up to next. That'll give me the shape. All right, 3-4, we can do kind of the same thing. And it is also in metric, so we'll get that started before we look at it. All right, so 40 and 15. Let's see, 25 would be 15. So it looks pretty consistent. Where the thin feature will fail is if this is called out as 10 and not seeing it. So it's either going to be 70, 15, not really given on the height. Got to make the assumption there's not really enough information there. All right, so one this way, one this way, one this way. We had 70 on the height, 40 on the lower leg, and 60 on the upper leg. All right, so alternative. I'm pretty sure I'm going to do the thin feature. Just to do it again, because we probably won't do very many thin features. Maybe one or two more that will show up. Keep in mind you can do the offset entities, and it's going to be 15. And I want to, let's see, is it going to let me select the chain? No. All right, so it finds based on select chain. Let's see, we're going to reverse it inward. And I'm going to cap the ends with lines. And that will carry it around through the same basic process. All right, if there was something else that I wanted to include in this sketch, maybe there's a hole or there's notch geometry or something, this would be the better option if I was including a nested feature or another piece of geometry in this sketch. Okay, so since I'm going to stay with the thin feature and contrast it, we'll go back in, reverse the direction. It's going to be 15 millimeters, and the depth of 50. All right, so 20 and 25 is 45. 45 and 25 would be 70, so that's centered, and 15 and 20 is 35, and another 15 would be 50. So design intent says I want this rectangle centered on that back face. So I can go center line, and my preference has been to go corner to corner. It usually does not interfere as much with other geometry, but you'll have to try it and see what works. And so we're 20 by 20, and I'm going to set those equal. And then that one can extrude cut. Shouldn't matter if it's through all or up to next. All right, so 15, 15, not a rectangle, or not centered on the face. So we'll go with a standard rectangle. And we are 15 by 20. And it is 15 off of the face, but it is still centered vertically. So a couple of options, probably the one that makes more sense is that if I were to go with a center line between the midpoint and the midpoint and make it horizontal, that would give me an obvious that they were that they're related. Select midpoint, right click, select midpoint. Nope, not going to let me have that one. That may be why I do the nope, it's going to jump. So if I can get the midpoints, then I could relate those horizontal. So one of the places where I could potentially sketch a point and it's just that little asterisk looking thing. And select midpoint. Okay. If I do it in the right order, then I can go horizontal. Alright. So we don't get to use very many points, but a lot of times when I do the points outside of the hole wizard, it's intersection of something that isn't quite as convenient to get to otherwise. Alright, so extrude cut, and up to next. And there again we have those fun square corners. So whenever you see square corners, that should be a red flag. Are we 3D printing this? If we're not 3D printing it, then my round tools do not make square corners. So are we wire EDMing it? Looking at it on the sides, we have an intersection. If I had done the through all, I probably did that on autopilot. I went up to next instead of through all, because through all will do exactly what it says it's going to do. Blast it through the lower leg. Okay. Alright, so let's see what we get next. Alright, so this one is a pretty good case for the offset geometry, and maybe has some symmetry, so we could mirror. So kind of looking at the base and drawing that from the top. That's going to be my strategy, and then I forgot to look if it's, yep, it's in metric. And I'll go to the top plane, pick my center line, vertical, infinite length. Let's see, it doesn't really matter, so if I were to go from the center point over, back, and up, and over, all of that, well, let's go ahead and put the dimensions on. There we go. 100 on the length, 50 on the depth. Yep. Still had that center line picked. And 25 on the step. And 30 on the leg. Okay, so now we can do the window pick from right to left. Want everything included so that when I mirror, I get my geometry. We're going to extrude this out some distance. So we had 30. That's going to be 15. And then let's see, our thickness was 10. So we don't always have to do the center line infinite length. So if it's easier, and I'm pretty sure I'm not going to overrun this line with my geometry, I'll go with it. Let's see, we're going to go full edge and a partial edge. So if I select those two edges, and I'll rotate over a little bit so you can kind of see it better, we have the tool called Convert Entities. And Convert Entities is probably my second favorite tool. And it's going to take those edges and give me an on-edge relation. The endpoints show up in black, but it's fooling you. We can grab that endpoint and drag it because it's on edge as long as we leave it alone. As soon as I do anything with it, endpoint goes to blue, but I can adjust it to size. And so 40. And then we'll go with that offset selection. So offset entities, reverse, 10 millimeters is correct. We're going to cap the ends and let it go with the lines. And then that gets extruded out. We'll go with the 15. Okay. And then, oh, I forgot to mirror. We could grab that and mirror it across the center line. Another one to be careful of or to be aware of, depending on how you look at it, is that we can also mirror the feature. So I have a mirror feature command that says the face or plane, because it needs to have that as a reference, is going to be the right. And features to mirror, we can also mirror faces, and then a lot of times we'll end up mirroring bodies. All right, but bodies are kind of the special case. Once you pick features, you're locked into features. Once you pick bodies, you're locked into bodies. It's going to drive your selection. Once I select the feature, it shows me the preview. We'll go ahead and accept. All right, so not nearly complicated enough geometry to really justify the feature mirror, but it gives you another tool as opposed to doing this out of the sketch. We can mirror the geometry over as a feature. All right, what next? 3.6. All right, so step. Maybe we'll do this with the offset. Again, file new, and that was a metric since I'm jumping right into inch. Okay, so the zigzag will go up. Oops, over. Go back and select it while I'm seeing it and make that horizontal. All right, so going this route, I have to decide which one's interior, which one's exterior, because even with the offset, I'm going to have to account for the thickness of the geometry. All right, so if I go with the top being at 40, then that says the material is going to go down. Well, we're going to have to double check. So let's see. 40 is to the step, but that doesn't take into account the thickness, so I believe that's going to be 30. And then if that one is 50, that one should also be 40. That doesn't look like they're drawing. So what did I miss? 40, 50. All right, well, we're going to see it in the offset, so I can take some measurements. Offset entities. 10 millimeters is, double check, material 10 millimeter, SA 1020 steel. 10, 10, 10. All right, well, we're going to go with 10 millimeters. We need to select something. Said we were going to reverse the direction again. All right, we'll go ahead and accept it. So it gives me the thickness, and then the lower one is 50. All right, so that looks good. Length of 30 millimeters, so that one changes to 40. And then that one we set at 40, so that should be good. That looks a little better anyway. All right, so I'm going to go back and double check, and then keep in mind any of these dimensions that we can always make this dimension driven. Hit OK. It'll be grayed out, but it gives us an immediate reference to go back and double check our numbers. Okay, and previously, before I did the reset on my options, I had checked the don't show again. In my workflow, I will eventually pick up, or I will recognize that I am putting in those driven dimensions. And so it warning me every time it sees one is not part of my workflow. Go with the dimension and then come back as we get closer to the solutions. All right, so 40, 50, 40, extrude, and we're going to go to a depth of 40. And I'm going to go for the mid plane again. So splitting 20 on either side. We'll do the upper notch first. All right, since this is going to go all the way through, we have that nice origin there, so I can make that my midpoint. Oh, and it's going to stop short of the 40, so what would that be, 25? And let's see, we had 15 from the end. Oops, helps to be in the dimension. I already said it was centered, and 10 both sides. So 20 in the middle. And extrude cut. Alright, so since our dimension is off of this face, this is someplace where I could do the offset from surface. And that dimension is 15. We need to pick the surface and tell it where to stop. Alright, so this one I don't have to reverse, I don't have to flip or translate. It makes the notch. If this was a through all, I could potentially put the second notch over here and go ahead through. I could also draw the notch on the lower, still on that plane, and it would stop short with the extrusion, or I would pick a selected contour and region, and then come back as a second sketch for the notch. So at some point I get a little carried away with the contours and regions, and it's easier just to create the separate feature and do the sketch. So 10 on both sides. This one is still going to be 15 deep, and for whatever reason I really want to make it 16. We're going to select the midpoint, select the edge, make the midpoints, and then because of the ability to project, I'm going to make those collinear. So now the dimension in this sketch drives the geometry in this sketch. Okay, so whatever this fits into, whatever function, is what I'm saying in my design intent is that these notches will always be the same. If I find out different, I go in the sketch, I remove the relation, I put in a separate dimension. But if you have even a basic amount of information, direction for this part, you know what your intention, your future, you know, what we would expect to be able to do with this in the future, and you can make decisions based on kind of that well, like I said, the magic crystal ball of design intent. Sometimes it's cloudy, sometimes it's a little cracked, sometimes it's perfectly clear. You come back in 3 months, 6 months, or a year and go, oh, we just needed to change that a little bit, and everything updates nicely or perfectly or with just a few minor rebuild errors. That's the best case scenario. All right, so again, looking at the geometry 3-8, I think I will do this one as a contour and region since the 15, 10, and 10 has the symmetry to it. So 30 and 30. And then we'll make one side the cut through and the other one on the shared sketch be the boss. Okay, and that is metric. So we'll go with the front plane. And we do have some symmetry, so why not? Center line, infinite length, vertical. And I missed, so I'll just do the control select. Okay, so we have the 80 overall. Let's see, that's another one of those, not sure what they're pointing at. So the leg, it looks like 20. Don't want that one, there we go. So hitting the escape clears me out of the pre-selection. So let's see, that one's 30. The center is 20. Okay. So that makes sense, that'll add up. Overall height, okay, so that's what I'm getting confused at is, it looks like this one's going back to the overall height, 10, 20 to the base. 30. So if we went 10, 10, 30, that would be 50, but not specifically called out. All right, best guess. And it's still the thin feature because I'm got in a hurry and didn't mirror. All right, depth is 60. All right, so opening the sketch on the face, we'll go Control 8, Normal 2. Go ahead and put in my center line. We'll go with the rectangle. $10, $20, and then we had 10 for the center line. And let's see, the width was 15. So got the pre-select again. So escape to get out of the pre-select. 15. Let's do a select chain on this one and Control select the center line and mirror the entities. All right, so same geometry, except one's going to come out, one's going to go through. So if I start with the extrude, even though it's not open, it's not looking at intersecting geometry, I can force the selected contours. So this one's going to build out and blind in condition of 25. And OK. We highlight the sketch again, tell it to cut extrude, and force the select contours. And it still found sketch 2 on that one. So I'm going to remove that out of the list to make sure that it stays with just my region, not with the whole sketch. And then that can be up to next or through all. I have our geometry. Oh, that was 8. Which one was 7? Oh, I didn't go down far enough for 7. Okay. All right, so let's see what 7 looks like. There we go. All right, so our notch geometry. Now that looks pretty much straight through. We could go with the offset or the thin feature again. And this is in inches, so now let's go with the thin feature. All right, so another, well, no, that's not quite rectangular, is it? All right, so 1 over, 1 up, 1 over. And I don't think that one's going to be quite that long, so 2 inches. Height of 1.5. And we'll go with the length of 1.5. All right, so it stayed blue, which usually means that it can rotate, or something did not enable the inferred relation. So I go back to the selection, find out why. Well, first find out why it's still in blue, and then make a decision on the relation that it needs after the fact. Go in, extrude. Let's see, we have a thickness of 1/2 inch all the way around. Oh, that was the depth. 2.5 inches for the depth, and 1/2 inch for the thickness. All right, so is it going the right way? Yes. And then 1 notch comes up even. So I'll be able to pick up that geometry, not quite to the midpoint, so 1 inch back from the edge. And then that one can cut through. Oops, I'm going to go ahead and close up the from, I'm not using it. Up to next, or through all. Okay, so that chops the corner. Well, jumped into the rectangle probably a little sooner than I needed to. We could do 2 rectangles stacked on top of each other. That would put me into the contour and region, but it would be yeah, let's do that. I'll leave that one there. All right, so if I go 1 rectangle, select midpoint, and then I need to double check the center, 0.75 both sides, 0.5 both sides. And I lost my, oh, it grabbed the face, so make sure I'm on the edge. Select midpoint, select edge, go midpoint, and the outside was 0.75. And the depth was 0.25. And then if I line up a second rectangle, select midpoint, and we go 0.5. And then the depth of 0.5. So the only real difference is I didn't have to sketch the geometry. I sketched the 2 relation, or the 2 rectangles, and got them related. And then if I go to the extrude cut, it's going to automatically be in that contours and regions. So 1 contour, 2 contours, and up to next. All right, because again, through all is going to go all the way through the part. And with the intersection there, yeah, part's already complicated enough. All right. So again, it's not so much that your geometry, my geometry, is right or wrong. The only real test is the validity. Do you have the same volume? Do you have the same mass? Does it have ultimately the same dimensions? How you get there and what this looks like is going to vary between every person in this class, for the most part. All right, so 7. And we'll finish up on 9, and then that will leave getting into the assignment for next Tuesday. So still running behind. Perfect. All right, so new metric part, and we'll jump over to the geometry. So we can sketch this. You know, kind of on first look is to sketch the bottom and bring it up. But then in that same vein of what I just did with this notch, if I went with the offset and then another rectangle on the bottom, I could utilize those contours and regions to have a shared sketch. I think my first instinct on the strategy, though, is to draw the rectangle on the bottom, extrude it up on the right plane, find this geometry, and extrude it out. So I'm having too much fun with the contours and regions, so I'm going to go with I'm going to go back to that first instinct. All right. The other thing is I'm looking at these with the eye of how to generate it in this orientation. If I go to isometric, it is not a requirement that it look like this in isometric. If you drew this on the top and it went left to right and it shifted over into the southwest isometric as opposed to the southeast, I don't care. If I lay my geometry on top of your geometry and or we do a comparison, it's still that comparison, that validity test that makes it good geometry. All right, so top plane. Open the sketch, and I am going to use the midpoint to my advantage. Those right planes and other things, and the geometry I can leverage to come up with some numbers that will help me. So we're 40 overall, and this is going to extrude 10 millimeters. On the right plane, then, I can open up the sketch. Oh, maybe not the right plane. Front plane. There we go. And we'll zoom out a little bit. And we'll go up and over. So this should be the 50 minus, or 55 minus 10. And we had a height of 40 from here to here. So that should be direct. And we'll go back into the offset and select our geometry, reverse it to the outside, and make sure that it's at 10. We have a different thickness. So my geometry fails. All right, the offset I may still be able to do something with, but we'll have to see what plays out here. All right, so if I continue with the offset, then this line is going to have an offset distance and an offset 0, or just the offset. So let's see what happens if I get rid of the offset distance. Well, that pulled it for that line. How about that one? Nope. Pretty much losing my geometry, but, well, except for a few relations. Okay, a handful of relations. More relations than I would have expected. I get the geometry built out for me, but I have to complete those relations. All right, so 15 on the vertical, 10 on the horizontal, and then we can extrude. So I guess the takeaway is that you made a choice, found out it didn't work out. Doesn't mean you necessarily have to back out of it. But you have to be prepared to take that different path. And midplane on 40. We'll set the distance. So top one. Let's see. We'll go to Control 5, and I'll go with the sketch. Let's see. It is centered. So centered is going to be the center point of the circle back to the origin horizontal. We'll set some distance, or diameter, 30, and then 25 off of the leading edge. Right, and then that would go all the way through if we let it. So features, extrude cut, make sure to do the up to next, or up to vertex, or up to surface. And then we have 20 millimeters, and we haven't done Hole Wizard yet. So S key and Hole Wizard, or come up to the command manager and Hole Wizard. Simplified hole, ANSI metric, not a dowel. It's going to be drill sizes, and 20 is going to be down here as a ways. So, and in condition as long as we're on the top side. One thing of note, if you do include the countersinks. Basically, this is going to be a 0.025 countersink, or edge break on that leading edge. So that 0.05, you split that, and that is what the depth, or that's what the size of the countersink would be. Problem is that with all this geometry in the way, good luck getting a countersink in there. So might as well just call it an edge break, and we'll be done with it. Oh, there's one more hole on the back side I'm trying to miss. All right, so do I want to pattern this or just go ahead and draw 3? Yeah, we'll draw 3. Select, control, select. Those are going to be long leg is horizontal, or sorry, long leg is vertical, short leg is horizontal. And it's showing me vertical kind of as the little dashed box saying hint, hint. Go ahead and make it vertical. And if we use the dimensions, then we'll pull 20. Oh, I still didn't get into the dimension. And then 2 times by 30, so that would be what, 15? And let's back out of that. So 15. No, that doesn't work. Oh, 2 times by 30. All right, so both of those are 30. All right, and then from the back edge forward, 20. And with those relations, that should get it really defined. All right, so again, the advantage of the, and let's see, is that one centered? That one might be. Yeah, we could probably, well, those are pretty close to the edge. So that would be a trick, machining it in one direction. I'm going to say the advantage is that if I wanted to change over to a counterbore or countersink, I can do that seamlessly. The top one, I would either have to generate the geometry or delete it and go back in with the whole wizard. All right, so last one. Let's see, we have a 20 is for the 2 holes, so we're going to center over the origin. And then I need a dimension, 20 from the lower edge, so not that one. So I'm not sure what I had selected there, but that wasn't it. And then features, extrude cut, and through all. Save it. All right. Okay, so if you're watching the previous semester's videos, those are probably well, I say this group is not in most of those, so this is kind of a good spot to do what I would say is non-traditional or like commonplace strategy. Throw out some of those ideas with the offsets, with the thin feature. Experiment, try with them, see what works for you, but always be prepared to go back to your core strategy that says, if I draw this and I draw this, I'm going to be successful. And then you can expand out from there and do the experiment, see what works, paint yourself into the corner, get frustrated, just don't throw the computer.